Welcome everyone for joining us in this behind the scenes seminar series. For those of you who don't know us, since I expect that some of you will be from computer science, I'm a behavioral economist. I'm at the University of Oxford, and I'm co-hosting this seminar series with Vatsal, who is in Exeter, who is a development slash behavioral economist. And today we have the pleasure of hosting Nihar Shah, who is in machine learning and computer science. You've thought a lot about the science of evaluation and evaluation of science, as you put it very nicely on your website. As it's very obvious from your slides, you love minions, which we're going to see a lot of them. And we're super excited to have your perspective on peer review. It will be really fantastic to hear how all of this works in computer science. So welcome there to BTS.
Thank you so much, Sev, and thank you so much, Vatsal, for organizing this really novel type of seminar and for inviting me. So everyone, please feel free to interrupt in the middle if you have any questions. Please don't hesitate. Just unmute yourself and shout out the question.
Yeah.
Um,
Yeah, just before that, Vatsal is going to say a few words about the logistics so that you don't have to do this, and then we can focus on our presentation.
Amazing. Thank you everyone for joining us, and thank you Nihar for joining as well. So just for our audience members, and especially those of you who haven't joined us before, the seminar format is slightly unusual. So we'll have Nihar giving us an introduction of the paper for around 15 minutes or so. And after that, I'm going to share a link for a survey with you where we're going to elicit your beliefs about the production process of this paper, the behind the scenes of this paper. And then you'll have about 5 minutes or so to fill your responses. And then we're going to share the screen and show what you predicted and compare them with Nihar's responses. And then the rest of the seminar is going to be about the behind the scenes. So just in case you haven't looked at it already, I have just put the link to the consent form on the chat because, of course, we're collecting data here. And I think that's pretty much it. And as we spoke to Nihar about this as well, so feel free to ask questions at any point throughout the seminar. All right, Nihar, over to you.
Awesome. Thank you, Vatsal. So I'm going to talk about a peer review and in particular about mitigating a certain kind of arbitrariness. And I'm going to use tools from machine learning and social choice towards doing this. Okay. So this is joint work with Ritesh Nutigattu and Aryal Procaccia. And before I discuss this work, I'll give you a little bit of context about the peer review and publishing culture in my field, which is machine learning and artificial intelligence. So in my field, we not only have journals, but we also have conferences as a primary venue of peer review and publication. So unlike most other fields where conferences review just abstracts, in my field, conferences will review full papers, not just abstracts. And the conferences are reputed as high as journals. Conferences are frequently a terminal venue for publication, again, just like journals. And they're also highly competitive. Typically, we have 15 to 25% acceptance rates. Okay. So as a mental model, if you're used to our journal review process, you can think of our conference review process as a synchronized journal review process where you have one deadline for everyone to submit and one deadline for reviews and so on. Just as a side note, anecdotally, people think that conference reviews are fast, although they are a little less thorough than journal reviews. Okay, so with that context, let me go into our work. And the kind of arbitrariness that we are going to discuss here is where reviewers have differing opinions about the relative importances of different criteria. So what do I mean? So let me show a toy example. So let's say we have two reviewers who are reviewing some paper and both of them think that the novelty is 10 out of 10. So in the numbers I'm going to show you, higher is better. Okay, so novelty is 10 out of 10, fantastic. Results are 8 out of 10, which is also very good. But the clarity is 4 out of 10. It isn't written very well. And the reviewer on the left says that, hey, clarity is more important. So an overall score of 3 out of 10, which is like a reject. Whereas the reviewer on the right says, hey, that's okay. Clarity doesn't matter so much. Overall score 8 out of 10, which is like an accept. And so we see here that both of the reviewers are in agreement about, say, how much novelty there is, how good are the results, how much clarity there is. But the way they map these individual criteria to come up with an overall recommendation is different. So this is what is called commensuration bias. That is, reviewers have different mappings from the individual criteria scores to the overall scores. And there's a bunch of literature discussing this problem, and that it leads to arbitrariness or unfairness in the review process. Okay. Any questions about commensuration bias? Yeah. If you have any questions at any point, please just unmute yourself and ask. All right. So in 2015, Carol Lee wrote this very nice paper about commensuration bias in peer review. And this is a quote from her paper, which says that in peer review, reviewers, editors, program officers must make decisions on weighing the relative importance of different criteria, and not all criteria get equal weight, and these weighings can vary across reviewers or contexts even when reviewers are given identical instructions. Okay. And this can cause problems. Like, as another toy example, let's say that the reviewer on the left thinks that novelty isn't really useful unless the proposed algorithm in the paper improves the state of the art by at least 10%. Whereas, let's say most of the community thinks that no. Novelty is also really important because it can lead to big breakthroughs in the long run. Right? So now if there's a paper which has novel ideas but offers just a 5% improvement, the reviewer on the left would reject. Any reviewer from the right would accept. And so if the paper just happened to go to a reviewer on the left, then it would just get rejected, right? Whereas in most cases, it would have been accepted. So this is the kind of arbitrariness that we're talking about. Okay. So now the key question that we started asking was the following. So there is a lot of literature discussing the problems of this commensuration bias and the arbitrariness. And so the question is, well, how do we ensure that every paper is judged by the same yardstick? And as an aside, I'll note that while we're discussing this in the context of peer review, this has a broader applicability. For example, like if you go to TripAdvisor or any other product rating website, you have various individual criteria like value, location, etc., and an overall score, right? So now, like, your commensuration bias can be different from mine, and so you might value, say, the location much more, and I might generally value the service much more, right? So there's no one fixed weighing for all of us. And this applies to many other settings where we get evaluations from people, like in hiring, admissions, crowdsourcing, competitions, peer grading, judiciary, etc. All right. So now let's formulate the problem a little more concretely. So in our setting, each reviewer, whenever they're reviewing a paper, they're given some K predefined criteria to judge the paper on. Okay, for example, originality, strength of results, potential impact, and writing clarity. And then the reviewer is also asked for an overall recommendation. Okay. So the reviewer gives to the paper K criteria scores. So these are K numbers as an overall score. Okay, so that's another number. And again, formulating the problem, formally, like the problem is that different reviewers have different ways of mapping the K criteria scores to an overall scores. Okay? And what we want is a common mapping for all papers to mitigate the arbitrariness. All right. So back in 2013, in one of our major conferences, which is called AAAI, the conference organizers had an idea that, hey, there is this problem of commensuration bias. And so what they tried was a handcrafted design with a similar goal. In this conference, the reviewers were asked to score papers along 8 criteria, and the organizers provide detailed instructions on how to map the individual criteria to an overall recommendation. Okay. So it's just the organizers who had provided this rule. And while the goal was admirable, there were a ton of complaints about this handcrafted design. Yeah. And if you think about it, the organizers had to manually specify an 8-dimensional function, right? A function that maps 8 criteria into an overall score, and that is challenging. And so there are various things that didn't go according to plan under their rules. For example, their rule was that you should give a strong accept when a paper gets a score of 5 or 6 out of 6 for at least one criteria and does not get the worst possible score 1 for any criteria. Yeah. So this implies that, well, if the paper is just written very well, right, you strong accept even though it's way below par in every other criteria. Okay, so the handcrafted goal didn't work very well. And so instead we took a different approach based on machine learning to learn a mapping. So what do I mean by this? So first, for each review, we'll obtain the criteria scores and the overall score. For example, in our earlier toy example, we had these 2 reviews with the criteria scores and overall scores. And then we'll also have a bunch of other reviews. And now from all of this data, we will learn a mapping from criteria scores to overall scores that best represents the community opinions on how to map the criteria to overall scores. Okay, so for example, the algorithm would say that based on data from all of these reviews, the criteria scores of novelty equal to 10, results equal to 8, clarity equal to 4 should map to an overall score of 7. And finally, for each review then, we'll take the criteria score and apply the algorithm's output to these criteria scores. Okay, so the learned mapping is applied to these criteria scores to obtain a more calibrated overall recommendation. So for example, from the second bullet, we saw that the algorithm says that novelty 10, results 8, clarity 4 should map to 7. And therefore, for the toy example at the top, we'll replace the overall scores of 3 and 8 by 7. Okay, so that's the overall approach that we have. And so the crux, the technical crux of this is how to learn this mapping, right? So what is the algorithm that we design? What principles do we use to design this algorithm, to evaluate it, and so on? Okay. Now, before telling you about it, I'll just mention one common misconception that often exists when we think about combining different criteria into a final score. Okay, so I'll take this quote again from Carol Lee's paper that I had quoted earlier. And in that, she talks about how to weigh the importance, and weighing can vary across reviewers and so on. Now, I'm not exactly sure what mathematically she meant there, but one common interpretation of such weights is that it's assumed to be linear. So we often just assume that there's 20% weight on novelty, 5% on clarity, and so on. But this is a problem. Linear weighing cannot capture many useful rules that you might want to have. For example, accepting if all criteria scores are above 6 out of 10, or even for binary valued criteria, There are various useful rules that you can prove easily that no linear weighing can capture. Yeah. So in our work, we are not making any linearity assumptions. We won't get just one value of weight for each criterion, but instead we consider a function. So any possible function from the K criteria scores to the overall score. And the only restriction on this function is that it's non-decreasing in each criterion. Okay. So if any criterion value improves while nothing else changes, then the overall score should not go down. These are the kinds of functions we care about. All right. So broadly, our approach is the following. So key challenge is that there is no ground truth here. Right? We have no idea what are good papers, bad, what to accept and to reject. And therefore, instead of taking directly a supervised learning approach, we take an axiomatic approach. Now, as many of you are from the economics background, you might know this is popular in economics and social choice theory. And essentially what the axiomatic approach does is that it identifies certain special cases or special scenarios that are easy for us humans to reason about. And then under those scenarios, it establishes some necessary conditions or axioms that the outputs must satisfy. And then you use these conditions or axioms to narrow down the possible choices at hand. Okay. Now, very frequently it turns out that under some reasonable axioms, there's no possible algorithm that works. Right? There are famous negative results. Or often it happens that there are again lots of different choices and you still don't know which one to use. But anyways, we started with this approach and we established three axioms which we think are quite natural. The first one is what we call consensus. That is, let's say if everybody maps novelty 10, results 8, clarity 4 to an overall score of 7, then your algorithm should also map that criteria score to 7. Second is dominance, which we say that if paper A is at least as good as paper B, where the at least as good as is formalized in our paper, and I can go through it later if we have time and interest. But if paper A we agree is at least as good as paper B, then the resulting mapping should also reflect that. Okay, that A should get an overall score at least as high as paper B. And the third axiom is strategy proofness. That is, no reviewers can strategically manipulate the system. Okay. So all of these are formalized in the paper. I'm giving you the higher level overview. And then based on these, now here are the main results that we have. First, we propose an algorithm, and the key component of the algorithm is to do the following. So to find the coordinate-wise monotonic function, which minimizes the L11 loss from the data. Okay, this is like I won't have time to go into the details, but I'm happy to tell you more about what this is doing. And then what we prove is that this is the only method that satisfies the three axioms that I had mentioned earlier. So we were very lucky that we didn't get an impossibility and neither we get a huge number of possible algorithms to choose from. Okay. And finally, we applied this to a data set that we had access to. And so I'll just show you what the learned mapping looks like. So this is from the ICHCAI 2017 conference, and they had 5 criteria. And we saw that if, so 5 criteria, and we saw that the writing criteria and the relevance criteria were such that if either of them were really bad, then it reflected as a significant downside in the overall score. If they were really good, it was appreciated. And in between, there was a big plateau. where it wasn't really relevant. In terms of technical quality and significance, both of them had a high influence on the overall recommendations, and it was approximately linear. And the originality criterion had a moderate influence. Okay. So since then, this has been used extensively in peer review in computer science, and even in admissions process. And it helps mitigate commensuration bias. But alongside, we've also found a couple of interesting things. That number one is that we find reviews whose overall scores are significantly different from what the algorithm recommends. And then if you look at the text of those reviews, very frequently there are various problems. So we can also use this as a diagnostic tool to flag potential low quality reviews. And also it has helped improve the criteria. For example, we'll go back to somebody who was discovered to have a high commensuration bias, and we ask them, hey, what was going on there? And they might say, oh, I used this criterion as well in my review, which was not in the original K criteria. Okay. So finally, if you want to use this algorithm or even chat about these topics, please do ping me. I'm always excited to chat. I also have a survey on peer review more broadly if you're interested. And with that, I'll stop, and I'm very happy to take more questions.
Amazing. Thank you so much, Nihar. Yeah, and the survey is incredibly useful and interesting. Speaks to a lot of issues, not only in peer review in computer science, but actually across a broad range of disciplines. So it's a fantastic review, and yeah, I really recommend to anyone who is interested in peer review.
Thank you so much.
That's how I think you're going to share now the link to the forecasting survey. So we, if you guys can fill it out, provide your own predictions, then we'll be able to contrast your predictions with what actually happened during the journey. Let's think about this for 10 minutes. And meanwhile, we're just going to continue a little bit the conversation with Nihar on this topic, broad topic of peer review, because I'm really wondering how you came to working on this topic. Was it bad personal experience that led you to think we need to fix this? Let me fix it. I need to work on this. Or is it a matter of collaborations? Like how did you come to sort of specialize on this topic?
Yeah, so my PhD was in like using statistics and machine learning and game theory for crowdsourcing applications, like collecting labeled data for machine learning. So I was already used to the problems involving data coming from people. And so near the end of my PhD, yeah, I was also pained by peer review, and there's hardly anybody working on formally on it. And so our field, I really like the fact that it's very collaborative, it's experimental, and so on. So I wrote an email to the organizers of one of our conferences that, hey, I have these tools. Do you want to work together to analyze the outcomes of the review process, potentially find recommendations for subsequent years? And they were on board, and we made a bunch of recommendations based on our analysis, which were eventually adopted by subsequent venues. And so yeah, that was a great starting point. And then when I started off as faculty, I thought this is a useful direction because it is very impactful, but not enough people are working on it. And so that was enough motivation to continue there.
Yeah. Wow. So while talking about impact, how do you think about creating impact from your work on peer review? I mean, of course, there's something about being concrete and pragmatic about recommendations in general, and I'm wondering how you think about this in general.
Yeah. So as I said, so our field is like, is open to a lot of experiments. And so like we do a lot of experiments to understand the effects of any policies and for evidence-based policy design. So that's one direction we pursue. But being in computer science, another direction we pursue is designing algorithms. So while I didn't go into much detail in the algorithm for today, like this involved a non-trivial amount of work. And we have similarly designed algorithms for many other aspects of the review process today, which are now quite widely used. So we design algorithms, we evaluate them in various ways, and then if anyone's interested to use it, everything's open source, and we also help them to run the code and use it.
Wow, that's yeah, I love the very sort of open science being embedded in practices. This is great. Yeah, if anyone from the audience has any questions, please feel free to unmute yourself or submit a question in the chat. And yes, we'll take 5 more minutes maybe for filling out the survey. So if you haven't done so yet and you want to participate, please do so.
So, Sam, can I make a comment on the survey and on the seminar itself, and potentially of interest to the broader audience? So I'll build on an experiment that we had done in one of our top conferences, where what we did was the following. So we asked authors who had submitted multiple papers to provide a ranking of the papers they submitted in terms of their own perceived quality of their own papers. Okay. And then we did two things. One, we compared the ranking given by the authors with the ranking induced through the peer review process. Okay, so note that the ranking given by authors was not at all a part of the review process. So it's completely independent. And what we saw was that the agreements between the review process and the authors was in a ratio 2:1. That is, there was a 66% agreement and 34% disagreement. Okay, this is between the review process and authors. But now what we did, and this will lead to the question about the BTS as well, is that we also then saw which were pairs of authors who had co-authored two or more papers. Yeah. So let's say Sev, you and Vatsal, you both have jointly authored two papers. So now we'll compare Sev's rankings on the two papers with Vatsal's ranking on the two papers. And then we saw how much is the agreement or disagreement. And we found that the agreement to disagreement was again 2:1 roughly. That is 68% agreement and 32% disagreement. Yeah. So co-authors disagree with each other almost at the same rate as their disagreement with reviewers. So now my question for you for the BTS seminar is, like, here you asked me to fill out the survey about like what aspect took more time and so on. Maybe you could try asking different authors to give independent responses and then see how well they align with each other. Can they even predict each other answers?
Yeah, I think it's a fantastic idea, and wow, what a fun! I wish I had enough time to read all the cool stuff you're doing, because this is also extremely fun and interesting, especially the kind of same level of agreement between co-authors and external versus yeah. This is really interesting to think about. I mean, there's so much subjectivity that. Yeah, how to solve and what way to put on various aspects of the problem. That's definitely something to think about. Well, since we're already there talking about the BTS, let's just maybe go through the questions, and yeah, I will go over them in maybe as in a group in some categories, and yeah, feel free to take it the way you want, Nihar.
Amazing.
Yeah.
I'll share my screen because I think we have the audience responses now.
Yes, I'll stop sharing.
Yes, and then yeah, Nihar, I can go through a couple of questions. Maybe I'll go through this question and the questions on peer review, and then you can again share your slides because you have some material on that as well. Okay, amazing. So the first question here was about the timeline, how much time it took you. So this is what the audience responses were, and you said it took you 4 years. So in this case, most of the audience actually underestimated how much time it took. We can just do a few more. How many journals or conferences do you think the researchers submitted to before the paper was accepted? Um, oh wow. Okay, you said four. Four, I think, was your response, and most of the audience underestimated that as well. Um, how many rounds of revisions do you think the paper went through? So here, I think your response was zero. There were no revisions, and as a result, I think it took you 1 month to actually then send the final version of the paper. Yeah. So these are the questions on peer review. I think it'll be nice for you to talk about all of this, and also, of course, feel free to share your screen now. Yeah.
All right, so let's go behind the scenes, and I'll briefly tell you what happened behind the scenes. So this was joint work with my then colleague at Carnegie Mellon, Ariel Procaccia, and his PhD student Ritesh Nutigatu, who TA'd for my class. And so I started discussing about these problems, and this was an interest, like this was a problem that people had pointed out in the literature, but there was no algorithmic solution to it. And so this was like a perfect fit to pursue. We spent a lot of time in the mathematical results, like designing the algorithm from this approach and proving that this is the only method that satisfies the axioms. So that took a non-trivial amount of time. And then, yeah, the peer review process also took about 2 years um, because of, I'll show you. So we went through 4 conferences where we had rejections. One of the recurring complaints was the fit, because this paper was like a meta research intersection machine learning intersection social choice, and therefore not a perfect fit for anything, which was a source of many complaints. Uh, and then we also had comments which we didn't understand what was going on and like was mathematically not correct. But like you can look at our failed rebuttal to the reviewer where we had given up on this, and we said that the constant starting with the main issue with the result also stems from a misunderstanding, but we can't decide which misunderstanding it is because it seems to have many different misunderstandings. Um, and someone complained that this is rather straightforward. We felt it's highly non-trivial. We spent a lot of time, but we were not sure how to argue against this claim. And this was an opinion which is like their opinion, which is fine. Um, there was some technical incorrectness, like their strategy proofness makes sense only in a multiplayer game setting. But when you have multiple reviewers, it is a multiplayer game setting. I think they were thinking of just a single reviewer, and so that was some confusion. And then there is like it went to sometimes to reviewers who might have more of an applied background and not necessarily a more math background, and so they complained about certain technical terms that we were using. Um, and then like through the process we also made a bunch of changes. So for example, in our first version on archive, the title was choosing how to choose papers, which then we felt was too generic. And so then we spoke about like more technically it's about loss functions and axioms and peer review, and that was the final title. This notion of commensuration bias is something that we didn't know when we started on this, and we didn't know about this paper. And so we had read some other papers which vaguely referred to this, and our first archive version didn't cite this because we didn't know about it. And then later we discovered this, and so then we incorporated this, and it was great discovering this paper, and I'll highly recommend you to read Carol Lee's papers because like it very nicely frames the problem which we were addressing. We also had a cheeky footnote in the paper saying that even papers about peer review are subject to peer review, the irony of which has not escaped us. But yeah, we then had to remove the footnote as well. And there were other minor stylistic changes we made through the process. Yeah. And finally, yeah, we then decided to submit to a journal, which we felt takes a longer time but has more thoughtful reviews. And potentially because of all the revisions we had already done, and potentially because the journals are reviews are more thought through, we got this accepted without any revisions. And since then, this algorithm has been very widely used, so we're happy about that. Yep. Um, yes, I'll stop here about behind the scenes. If there are any
Amazing.
questions, I'm very, very happy to answer them.
So I have two questions. So
Yeah.
one, you said that it took you 4 years to finish this. How does this compare with the norms within your discipline and also your other papers?
Um,
And same for the peer review experience. That is it. Yeah, is it common? Because I think most of the audience underestimated how much time it took and how many rejections there were. Yeah.
yes. So in terms of the amount of time, it is much longer than typical. And probably because number one, it was not good, not a perfect fit for any venue. And second, this was not a problem that people in my field commonly think about. Right? So if it is a problem that people already have thought about, then you don't need to motivate the problem itself. And
Mm.
people are already in the know-how of the problem, the jargon, the notation, and so on. Whereas this was new to everyone. And that's
Yeah.
probably the reasons why, but it's much longer than a typical thing in my community and also my own experiences.
Right.
And so on average, how long do you think it takes you? Are we thinking about a year, 6 months? Like how fast does the process go?
Yeah. So our conference review processes are like 3 to 4-ish months. And maybe on average, like you submit maybe twice or thrice.
Mhm.
So yeah, like 8 months, maybe 8 or 9 months might be an average.
Right.
Yeah.
Wow. Okay, I'm gonna share my screen again, and then we can go through the rest of the questions. Um, all right. So the next one was, how much do you think the final results of the paper aligned with your original priors? Here you said not aligned at all, and again, I think the audience underestimated this as
Yes.
well. Yeah.
Yes. So maybe I think so. The way I was thinking about it was that like initially, like when we started with this axiomatic approach, we were almost sure that, well, either we are going to hit an impossibility or we are going to hit a point where you still have a large class of algorithms to choose from and you don't know which one to use, right? But we were just super duper lucky that with these axioms which we had set, we got exactly one result. That is, this is
Yeah.
the only algorithm that satisfies it. And that was not aligned at all with what we had initially thought.
Right. Um, okay, let's go on. I think this relates to something you already mentioned. How many times do you think the pitch of the paper was revised? And you said once. Okay, we've got most people agreeing on this. And how many times was the introduction change for stylistic reasons? Uh, oh wow, okay, that's 5 to 7 times. That's
Yeah,
quite a
it
yeah,
was I- mostly like not the full major introduction, more like not major changes. The major changes were like those which I mentioned in my slide, but a bunch of minor tweaks and so on to fit the venue where we were submitting. And
right.
so we made a total of 5 submissions. And then, like, once we discovered the commensuration bias paper, we changed the introduction to incorporate it. And then
Yeah,
some other minor stylistic changes here and there.
I see. Um, okay. So here this question was about how challenging each of these different aspects of the research process were for you. It's very interesting. I think we should think about like reaching out to co-authors and seeing how these match. So here the audience says data collection and writing and structuring the paper are the ones that are the most challenging. About data collection, I was also wondering that you'd have to have access to each reviewer's score on those various dimensions, which is how common is that again? Because I don't think we would have access to something like that.
That's pretty common. So in our field, there are many venues which ask for individual criteria scores and an overall score, and a lot of those reviews are publicly available. So we have a bunch of venues which are open review venues where, like, in some venues, like all the submitted papers, whether accepted or rejected, they are publicly available along with all of the reviews.
Yeah.
In many other venues, all the accepted papers and the reviews are available. And
Right. I see. Um,
Hey, can I ask you something about the axiomatic framework? So was it
yes,
clear for you from the start, the choice of axiom was clear for you? It was about solving, finding, what representation and what solution you could get, or did you also have some back and forth on the choice of axioms, knowing that you mentioned you struggled a bit with like the proof itself? So I was wondering about that.
yeah, great point. We luckily did not have to do much back and forth with the axioms. We did have some backup axioms that we had thought of, which we felt were like a lower priority than the one which we were considering. And we had thought that, well, if this leads to an impossibility or many results, then we'll consider them. Although, like, these three were our priority, and again, we were super lucky that it just worked out. But so proving it was hard, but we got an intuition like much earlier that it seems that we are going to get a unique solution. Just like actually formally proving it took a lot more time.
And how do you go about developing intuition for results, right? So, I mean, there's something about when you're not so sure, is it worth the investment? You know, at some point you might decide you want to quit because it's not clear it's going anywhere. And so do you want to think about getting some intuition for what's going on, and how did you develop that intuition?
Yeah, that's a great point. Like, one, we did a number of special cases and examples to start off. There's also some simulations that help. Um, and otherwise, somehow it's just like when we were thinking about like attacking the problem from different angles, in the like when we were trying to prove it, it all seemed to go in a similar direction, and that gave us more confidence about like, hey, it'll probably go this way.
Yeah, that's an excellent point. Thinking about simulations, it's a great way of developing intuition. And my students always think, oh, my model is not complicated enough. And often, well, no, it's not simple enough. So you want to think about examples and
Yeah,
two players, two dates, right?
yeah.
Two choices. That's exactly what we want. Mm.
okay. Um, we also have your responses, by the way, to the challenge questions, and you said that developing the idea and navigating peer review were the most challenging.
Um, yes, and here, like, so coming up with the research idea was like I also include the identifying the problem and
Yes.
formulating the problem. In developing, I'm also including like doing the proof, etc.
Hmm.
Um,
Yeah.
so the data analysis was the easy part because the main contributions here were algorithm design and then the mathematical proofs. And
Yeah.
then the data analysis was simply like running the algorithm on the data. And it's like a tiny part of the entire paper.
Yeah.
And then
Yeah.
yeah, peer review, it was just annoying to have like these reviews and doing the rebuttal.
Yeah.
But
So
that's fine. Like
yeah,
it's a part of life.
one of the pieces of feedback that you got in the referee report was that it is very much like the work on social choice theory. So here, did you have to like defend? How did you defend that? That
Yeah.
was not.
Oh,
Yeah.
so that was a final decision. Like there's no defending. Like that was a
Okay.
final decision which said that, hey, this is more social choice than machine learning, and so it's not relevant to this venue.
I
And,
see. Okay.
and we said fine, and we just submitted elsewhere.
Okay, then let's get to the last question, and then we can also open it up to the audience to ask any questions they want about the paper or the behind the scenes. So the last one was about time use on, again, the same aspects of the paper. And here, um, yeah, so the audience thought that developing the research idea wasn't as challenging as, like, let's say, data collection, but in time use, I think developing the research idea they thought would take the most time, which aligns with what you said. And that's your response right here. So they're quite aligned. Yeah, I'm happy for us to open it up to the audience for any questions now. Please feel free to unmute yourself and ask questions. If there's no questions, Nihar, can I ask you one question, which is about
Yeah.
about the seminar itself? Are there any other behind the scenes aspects that we didn't ask you about, but you would have liked to share with us?
Oh, good point. Um,
Specifically about
so,
collaborations and co-authorships as well, if there's some,
yeah,
anything.
I think one interesting thing that I'd be interested to know in, like, not just this, but in general research projects, is to, like, when we see the final paper and you have like four authors listed, it's like, hey, all four authors are endorsing everything. But there's during the research process, there are a lot of disagreements
Mhm.
throughout, right? And it'll be interesting to see, like, what were the disagreements and how were they resolved. um, like, not in terms of fighting for co-authorship, but like someone might like approach one and someone else might have liked approach two, and so what were the alternative approaches and how did you decide to pursue this approach, things like that.
Yeah.
So in our case, for example, like couple of us did have disagreements early on whether we should use linear models like the weight values and just identify weight values, or just a more general mapping which could be non-linear. And then eventually non-linear won and we used non-linear mappings.
Yeah. Okay. Does anybody else have a question?
How many of your co-authors are at Carnegie Mellon?
Well, for this paper,
In general, I'm trying to sort of think about social networks and how, geographical proximity and, sort of information transmission operates. Is it, local versus global? Yeah, do you have thoughts on that?
yeah. So I think during COVID, the global collaborations, I think, increased a little more. And then now, because of proximity, the local thing works little more, right? You meet them like in a social event, in a talk, and then you start talking about something. Uh, Good question. I don't have the precise number, but it might be like 70% local.
Wow.
It's just a guess. I have to count.
Yeah.
And what proportion of seniors versus juniors do you work with?
I think it turns out a very large fraction are more junior, on the junior side. Yeah.
Mhm.
Also, one thing is a lot of my research is on the math side. And so it helps if we do it on the board. And so if we sit together on the whiteboard, it's much easier as compared to using a Zoom whiteboard.
Mhm.
Yes, I can confirm. I remember the many painful experiences of teaching econometrics on a Zoom whiteboard, which I
Yeah.
complained so much about. Yeah, amazing. Well, if there are no more questions from the audience, thanks so much for participating. It's super interesting. I think you gave us more ideas of what we can do, and yeah, I think we should organize some peer review conference at some point because clearly there's so much we can learn from you about the topic, and yeah, encouraging a knowledge exchange in on a topic that just speaks to everyone, really. That's I think really important.
Yeah. Thank you so much. And if anyone wants to chat about these topics, I'm always excited to do so. So please send me an email.